one more type of mole problem to do. Okay, so this mole problem is mass to mass. So these are 3-step mole ratio problems. All right, so I'm just going to draw up here sort of the framework of what this is going to look like. So, excuse me. So what you're going to do here is, boy, that's awful. That looks ugly. Let's try that again. So what we got to do is we're going to do 3 steps. So the number that you start with here goes here. So whatever you're starting with goes here, okay? And then whatever that compound is, you're going to put the molar mass of that compound here. All right? And then the mole ratio is our next step. All right? So then the mole ratio step comes next. So this is going to be our mole ratio. So it's kind of like a sandwich because the mole ratio is the meat of the sandwich. Okay? So the mole ratio step goes here, and so here's what you're starting with, moles that you start with. And then over here is the moles of what you're looking for. Okay, and then the last step is going to be the molar mass of what you're looking for. All right, so and this is kind of the formula for any mass problem. So if you start with grams and end with grams, you have 3 steps. The first step is the molar mass of what you're looking for. Then you have your mole ratio. Molar mass, what you start with, mole ratio, then molar mass of what you're looking for. Okay, so let's try it. We have this, all right, so, and like we did before, I'm going to set up my train tracks. All right, so we know we're going to have 3 sets, so I'm just going to go ahead and make 3 steps here. Okay, there's my 3 steps of my train tracks. Okay, and it says determine the mass of lithium hydroxide, so that's what we're looking for, produced when, all right, 3.8 grams of lithium nitride reacts with water according to the following. And I balanced the equations for you, so don't worry about the unbalanced part because they're balanced. Okay, so let's see what we got here. Our starting number is lithium nitride. So here's where we're starting with. And our end is lithium hydroxide. So that's what we're looking for. And like we did before, I'm just going to write right under the balanced equation what we know and what we're looking for. So we know 0.38 grams of lithium nitride. So I'm going to write that underneath. And what I'm looking for is lithium hydroxide. So I'm going to put a question mark and grams. So that gives me a little roadmap here to know what to do. So my starting number, as always, goes right at the beginning. So 0.38 grams of Li3N. So we need 2 molar masses. We need the molar mass of lithium nitride and the molar mass of lithium hydroxide. So I'm going to do that over here on this side. All right, so get out your periodic tables. And let's go ahead and figure this out. Molar mass of Li3N. We're going to have 3 times the mass of lithium, which is 6.94, plus 1 times the mass of nitrogen, 14.0. How did I get? Okay. When we add these up, we get 34.83 grams. Okay, so there's the lithium nitride. Now I'm going to do the same thing on this side for our lithium hydroxide. Excuse me. Because we need them both. So for lithium hydroxide, we have 1 of everything. So we need 1 lithium, we need 1 oxygen, and 1 hydrogen, 1.01. We're going to add all those up, and we get 23.95 grams. Now we can put it all together into our train tracks. Okay. First step, we need to convert from grams to moles of what we start with. Let me highlight this. Oopsies, wrong color. Daggone it. Let's see if I can get rid of just the color. Stop it. Okay. So here's where we start with. Now, the first half of our train tracks is all about lithium nitride. Okay? So, and then the second half of our train tracks is all about lithium hydroxide. All right, so 0.38 grams of lithium nitride. So we're going to put our molar mass on top. So 1 mole of Li3N. And our molar mass is 34.83 grams. We just figured that out right over here. Now, next comes our mole ratio. So if we look at our balanced equation, we have 3 moles. What we're looking for goes on the top, and what we start with goes on the bottom. So we have 3 moles of lithium hydroxide. If there's nothing in front of it, that's a 1 for every 1 mole of lithium nitride. Now, our last step is going to be using the molar mass of the lithium hydroxide. So we just calculated that, 23.95 grams for every 1 mole of lithium hydroxide. All right, now we have our setup. If we did it right, our units should cancel. Grams cancels with grams. Moles of lithium nitride cancels with moles of lithium nitride. Moles of lithium hydroxide cancels with moles of lithium hydroxide. And ta-da, we have grams. So we're going to do the math, multiply by what's on the top, divide by what's on the bottom, and we get 0.78 grams of LiOH. Now, it's important to include units and the substance in these because we're converting from one substance to another. So it helps to keep you from getting confused. All right, let's do the next one. Same deal here. Let's take a look and see what we know. What mass of sodium chloride is produced when chlorine gas reacts with 0.29 grams of sodium iodide. So this is our starting number. And what mass of sodium chloride? So the sodium chloride is what we're looking for. Okay, let's write what we know in our balanced equation. I2 was hard to read, so I just rewrote it there. So don't let that confuse you. Okay. 0.29 grams. So we're starting with 0.29 grams of sodium iodide, and we want to end up with grams of sodium chloride. So over here, let's do the molar mass of NaI. Okay, so NaI, so sodium is 22.99 and iodine is 126.90. Those are the masses from the periodic table. So we come up with 149.89 grams. So that's our molar mass of sodium iodide. And I'm just going to go ahead and do sodium chloride on this side because we need that. This is the problem that requires all the stuff. 22.99, so 1 sodium and 1 chlorine, 35.45. And that gives us 58.44 grams. Okay, now we have everything we need, so let's set it up. Here comes my train tracks. Toot, toot. Okay, we need 3 steps. 1, 2. Oh, I made it a little longer than I need to. Okay, boop. And here we go. So what we start with goes, as always, the number given in the problem goes here. So 0.29 grams of NaI. What I'm going to do first is I'm going to use the molar mass. So the first half of my problem is all about the NaI, and the second half is all about the NaCl. So starting with what we're looking for and ending up starting with what we've given and ending up with what we're looking for. All right, first, grams to moles, no problem. So for every 1 mole of NaI is going to be 149.89 grams. Now I'm going to use my mole ratio. Oh, it's 2 to 2. 2 moles of NaI and 2 moles of NaCl. So the mole ratio comes, use the coefficients from the balanced equation. Last up, molar mass of sodium chloride goes in the final set of train tracks. 0.44 grams for every 1 mole of NaCl. Now let's cross it out. I love this step. Goodbye grams. Moles of NaI, yep. Moles of NaCl, yep. Final answer, grams. Multiply across the top. Divide by what's on the bottom on your calculator. And there we have it. So if we start with 0.29 grams of NaI, we're going to get 0.11 grams of NaCl out of the reaction. We're going to do 2 more on this page, and then you're going to do the next page on your own. I know you can do it. Okay, we want to know the mass of carbon dioxide produced when 0.85 grams of butane reacts with oxygen. Okay, what we're looking for is the mass of carbon dioxide. Okay, don't let that oxygen fool you, because we don't care about the oxygen. What we want to know is the mass of carbon dioxide. So we're looking for this. We're starting with butane. All right, let's fill in what we know. 0.85 grams. So we're starting with 0.85 grams of butane, and we want to end up with grams of carbon dioxide. So I'm going to, on this side, figure out the molar mass of butane. C4H10. Okay. 4 times the mass of carbon plus 10 times the mass of hydrogen gives me a grand total of 58.12. And over here, I'm going to do the molar mass of carbon dioxide. So 1 carbon, 12.01, and 2 oxygens, 2 times 16. 14.01. No, sorry, 44.01 grams. Okay, now we can set it up. Here comes the train tracks. Choo choo. Oh, I gotta stop doing that. Okay. All right, starting number goes at the beginning. C4H10. What we're going to do now is, you know what comes next, right? Molar mass of what we're starting with, and then mole ratio, and then molar mass of what we're looking for. We just figured it out over here. 58.12 grams for every 1 mole of C4H10. I ran out of room. Next is our mole ratio. So for every 8 moles of CO2 that are produced, I need to react 2 moles of C4H10. Last step, molar mass of carbon dioxide. 44.01 grams for every 1 mole of CO2. Multiply across the top, divide by what's on the bottom in your calculator, and we get 2.57 grams of CO2. Oh, I didn't cross it out. Grams, yay. Moles, yay. Moles of CO2, yay. And we're left with grams. All right. One last time, and then you try it on your own. Determine the mass of antimony produced when 46 grams of antimony 3 oxide reacts with carbon according to the following equation. So we're starting with, we want to know how mass of antimony produced. And we're starting with 0.456 grams of antimony 3 oxide. Okay, so let's write it up underneath what we know, underneath our chemical reaction. 0.46 grams. So that's our starting number. And here's what we're looking for. Okay. So let's see here. So this is where we're going to end up, and this is where we're starting. Molar mass. Let's do the molar masses, because that has to come next. So the molar mass of Sb2O3, 2 times the mass of antimony, which is 121.76, plus 3 times the mass of oxygen, 16.00. When you total that all up, you get 291.52 grams. So there's our molar mass of Sb2O3. And let's see, the molar mass of Sb, well, that's an easy one because it's just the mass off the periodic table. So the molar mass of Sb is 121.76 grams. No adding necessary because it's an atom. Okay, so let's set it up. Here we go. Starting number goes at the beginning, as always. Okay, I gotta finish this up because my iPad's dying. Molar mass comes next. So for every 1 mole of Sb2O3, we have 291.52 grams. All right, now we need our mole ratio. So let's see here. So we're starting with this. Here's that. Our mole ratio, we put what we start with on the bottom. What we're looking for goes on the top. Okay. It's a 1 to 2 mole ratio. So for every 1 mole of Sb, which is what we're looking for, we have, that's a 2 there. That's a 2, last time I checked. We have 1 mole of Sb2O3. Now remember, if there's no number there, that just means 1. Okay, so it's a 2 to 1 mole ratio. Last step, let's put the molar mass of antimony, and that's for every 1 mole of Sb. Let's cross them out. My favorite step. Grams of SbO2 cancel. Moles of Sb2O3 cancels. Moles of Sb cancels. And we're left with grams. So get out your calculator. Multiply by what's on the top. Divide by what's on the bottom. 0.38 grams of Sb is produced. Okay, so you've got 4 problems to do on the next page. Use these as a guide. And the answers are at the very bottom of the next page, so you can check your answers. You need to show your setup and show all your work to get credit for doing the problems. You can't just write the answer, because guess what? The answer's already at the bottom. Haha. All right, good luck. I know you can do it.